So if we actually look inside, what we have is our test button here, which illuminates the indication lamps to prove that the lamps work. And we also have our buzzer that will sound should our lamp fail. And as you can see, there's a little trembler contact just there. So as that breaks the circuit, breaks its own feed to the coil, drops back, makes again, energises the coil, picks it, breaks that trembler contact, falls back again. And that constant breaking is what gives you the buzzer. At the top of our unit, we see we have the nomenclature of what actually this indicates. We have our proving lamp to prove that the circuit has actually failed on that lamp, because if you have several buzzers and several of these on a block shelf and you hear the buzzer going off, the light doesn't instantly light, so you need to know which one it is. So you can press your test button and it will illuminate and show you which ones are lit, which one's not lit. The normal position for these is in position A. That is the lamp being made. When the buzzer goes off and you've identified which one it is that has actually failed, you can then flick the switch down to position B, which kills the buzzer off. The technician will then be called for come and change the lamp. When they've changed the lamp, the buzzer will go again, at which point you can then return switch back to position A, so everything's back to normal again. So if we turn our unit around and we actually have a look inside the back of it, what we will see is we'll see two twin coils, and for every unit we have two twin coils, so there'll be another two twin coils in that unit there. And what happens is that these are the terminals for the incoming voltages from the lamps outside on the ground. So if you imagine your lamp is lit in series with this will energise this coil, picking this coil up. Now as this coil picks up, there are three sets of contacts. This contact here is the lamp lit, lamp illuminated, contact made, and this here is our back contact, the lamp not illuminated contact. If we move in closer, we'll notice that there's a slight small wiping contact just here, which is normally made just there to that. Now what this is for the lamp proving on the front as to which circuit has gone. So as you can appreciate, should we lose our voltages on our coils up here, this relay will then de-energise and make this back contact. In making this back contact, the buzzer will go off. We will identify which one's gone by using our test button on the front to see which light's not lit, and then we can put the switch down from position A to position B, and in doing so that quietens off the buzzer. Again, when the lamp is replaced, obviously the contact will make as the coil energises. This will put the switch out of kilter with the relay coil, so then we will also go and flick our switch back to position A. So as you can see, when it's making, the lamp is lit. When it's broken, the lamp is not lit. And this wiping contact should at all times be making to this. That's why it's on a very thin spring leaf. Sometimes these get bent, and also what you end up with is a lot of high resistance here if they're carbonised, so you need to keep them really clean. The coils of the relay, these units are interchangeable, you can take them apart. Coils of the relay are wired up to those top two terminals there. There are numerous other terminals inside as well. For instance, these are the two coils for the next relay down, and there are some very fine, just looped up wire spring coils there to take it round where movement is necessary. There's a weight on the end of each of these, so when it de-energises it will power down, that will drop. These are adjustable, these terminals, and they do have a locking nut on them as well. So you just got to be careful you don't shear these things off. There's not much room to get a screwdriver in on. If we have a look in the base rear of the test unit, this is the back of the test unit and the buzzer, we'll notice several terminals. Now this terminal up here is the positive terminal. This terminal here is the negative terminal. Traditionally you'll find this wired across a B1 supply or a 12 volt supply. Out in sticks, there'll be standby batteries. And then this terminal down here, the BN that you think is common, this terminal is part of the circuit which allows you the lamp test facility on the front. One thing that you do see in here that you don't see much of nowadays, this is a built-up bridge rectifier diode, the old type, where I used to use the plates. And part of the reason for this is you can actually wire this off the AC supply for colour light signals. Doesn't happen much in the last 20 years, but I have seen some of these that have been wired off the AC supply. So obviously if you've got an AC supply, your buzzers will not work as such. So what you need to do is take the DC dropped out feed off that, and hence what this is for. When these go, you can interchange them with modern electronic components, but they are just plates, so they can be, you can actually repair them, but that's so you can borrow the AC feed off the colour light signals or your AC supply to your lights. So here I have a test one wired up, and as you can see the switch is in position A, so the lamp is lit as normal. And what we're going to do here, we're going to de-energise the proving relay, and it'll then buzz out. So this is what the signalman will hear. He will then cancel this down once he's used his test button to find which one it has that's gone. And then when the lamp is repaired again, it should find the relay. Re-energise. It's this one. And here we are, we're going to put the bulb back in now and watch it clear the relay. So it buzzes again, so at that point we'll flick the switch back to A. Now I just took my hand off the relay there, so as you can see, as soon as the relay re-energises, with the switch in the wrong position, it repicks. If the switch is in the wrong position, at all times, it will send the buzzer off until you operate that switch down. So finally what I'm going to show you now is the test button, and what I've done here, I've wired positive feed up to both the B and the BN feed on the bottom of the back, as I mentioned before, and the negative feed as well. Roughly about 7 to 8 volts it starts to work. 12 volts is nominal for this circuit. So presently, bear in mind this is just a test unit, we don't have any feed to our coils on this or these two other switches. We have this switch strapped out. What we have is a piece of cardboard in the back just to hold the coil up. And should we get a lamp failure, if we press the test button down at the bottom, which I took the face off so you can see what's happening, you can see that when you press the test button, that lamp lights, and that is in position A. So we know that lamp is good. If we press our test button again, we're getting no indication on these, suggesting that these are our failed signals. So we can test that and see no light there. Now, if I were to take out the piece of cardboard, it will buzz. That one's just failed, so we've just put it down to position B, it's turned it off, and we can also test it, and indeed our light doesn't come on, saying that the coil has definitely dropped in the back. So that's what we will call our S&T technician out to have a look at. So that's the BR standard filament failure indication unit made in Bakelite. One other thing to notice, when you take these double switches off the front, they have a little fibre Bakelite washer which just covers over there. They do tend to fall off, so just be aware of that. You can get at the lamp terminals on the front as well. They are moulded in through the Bakelite, but you can actually put your meters on these flying leads that come off here. And you will sometimes get some problems with little springs on the back of the old bayonet holders as well, which is a well-known thing if you've ever had Christmas tree lights that used to be outside of the same kind. And that's the BR standard filament failure indication unit. Here we have a hard copy of the standard wiring drawing appertaining to the signal lamp repeater unit that you've been looking at, and I'll leave a copy of this on the end of the video just so you can get a better view at it. And also I'm going to give you a picture of the earlier type of indicator where the actual contacts of the filament failed indication unit actually act as part of the contacts of the circuit, and you'll see that picture next as well. These are lovely old indicators.